Greetings, IT&C 101 students. My name is Derek Hansen. I'm the program chair for the IT and cybersecurity program and a faculty member. I've been here at BYU about 9 years. Before that, I taught at the University of Maryland for 4 years. I studied economics as an undergrad here at BYU, and then went on to get my PhD in information, whatever that is, from the University of Michigan. And in between, I worked as a consultant, as a data analyst. So anyway, I'm thrilled to be here. I wish I could be presenting this live to you, but I'm doing the best I can. This is being recorded in the semester when we are going virtual for the first time due to COVID-19. And since I could put myself anywhere, I put myself in the Computer History Museum, which is in California, San Jose. If any of you have been there, I think you'd agree it's an amazing place. I got to work with them on a Ghost Escape the Museum project a number of years ago, where we had classes of students come through and learn about different historical figures like Ada Lovelace and Charles Babbage and Alan Turing. So anyway, I'll be talking a little bit about the history of technology today. It's a topic you could spend, a whole semester on. So we won't go super deep, but it's, I hope it'll kind of be a teaser for some things that you might want to do in the future. I wanted to start by introducing myself. I'm going to actually turn on a screen share here so that I can show a couple things on this. So let me just open up my personal website here. I thought I'd introduce myself a little bit more. So here is a website that kind of spotlights some of the projects I've worked on. This semester, I'm really excited because we're about to release the Eureka Trail, which is a mobile app that encourages you to take more steps during the day as you and your friends virtually trek across the plains during the gold rush. It's kind of a mix between the Oregon Trail classic computer game and a fitness tracker. But we've re-envisioned the whole thing and gotten some cool work from artwork that we've been able to sort of modify and use in the app from the California-Oregon Trail Center in Montpelier, Idaho. I'm also working on a startup company called LoomView. We created a Chrome browser extension that helps you learn a language as you read. So we flip certain words into a target language. And that's work with David Wingate, who teaches machine learning and computer science, and a good friend of ours, Grant Roberry. And then this semester, you might get to experience one of my other projects. So I've been working on what we call playable case studies with John Balzati and in the English department, and also like Justin Gibney and Amanda Hughes here in the IT&C program. And we've developed some of these to teach new concepts in kind of a unique way. So you work with fictional characters in kind of a day in the life of, whatever the focus of it is. So Cybermatics is one of these where you get to take on the role of a penetration tester and kind of see what it's like to be a cybersecurity professional that does ethical hacking to break into a system that someone's paying you to find vulnerabilities in. In the past, I worked on some fun projects like the one I mentioned in the Computer History Museum. That was part of the Tessera. It was an alternate reality game that taught middle and high schoolers about computational thinking. And we had a cool online component to it where people could do sort of escape the room type puzzles and activities. And then the museum component, which was a lot of fun. We had an accompanying card game and some other fun things. And we did a couple other alternate reality games before that, Dust and the Arcane Gallery of Gadgetry. This was a fun one. The Rhythmatist is a book by Brandon Sanderson. I'm a big fan of his. And we built out a drawing-based battle game for a capstone project. It was a fun proof of concept. And then I've done various other projects. Maybe one that I'll mention down here is I've written a book and done some work on social network analysis of social media data sets. So it's really cool to see like what is the network of, Twitter followers or things like that look like. So anyway, that's enough about me. I would love to chat with any of you about, user experience design. I also teach courses in ethics and legal issues with cybersecurity and IT, and game design is a passion of mine, as you can tell. I try to do things that I guess have some element of public good, whether it's encouraging people to exercise or learn a language, or a lot of educational things as well. So I'm going to switch over here and talk a bit about the evolution of technology. So let's jump right in. So largely, the concepts I'll be talking about today were inspired by a book called The Nature of Technology by Brian Arthur. It's sort of in this field of economics and complex systems and what we call science, technology, and society. People who study the history of how different technologies and societies and science unfold over time. And there was a book actually that I remember reading as an undergrad here, 20 years ago, by Thomas Kuhns, that talked about the history of science and how you would have different paradigms that were sort of the orthodox view of the day. So like take Newton's, laws of physics, everyone kind of agreed that those made sense. And then over time, some anomalies started to appear, and it seemed like, well, we don't have anything to replace it with, but we're not sure why it doesn't quite hold up. And then along comes someone like Einstein and comes up with some of his, ultimately theory of general relativity, which sort of encompasses the former theories by Newton, but generalizes them more. And so you have this whole kind of revolution where we switch the paradigm to a new one. And then there's holes in that one, right? So right now people are scrambling to try to figure out how do quantum physics and general relativity relate to each other, and no one's quite cracked that yet. At some point they will, and then there'll be another revolution, and we'll, in the field of science, and then, so on and so forth. Well, we have a pretty decent understanding of how science unfolds, and Brian Arthur thought, no one's really done this for technology. But the way technology unfolds is quite different than the way that scientists describe nature. And so he goes through in this book, which if you're into this kind of thing, I think you might find fascinating. It's fairly technical, but well written and thought out. So anyway, we'll jump into that. So first of all, we might ask the question, like, what is technology? Some of you are going to graduate with a degree in information technology. You should probably have a good definition for it. Those of you studying cybersecurity also work with technology all the time. So one way to think about technology would be in the singular form. So we point to things often and say, that's a technology, right? So we could point to an axe and say, it's a technology. Well, what is it that makes it a technology? If we were in person here live, I'd be asking you, and most of the time students are pretty quick, to say something like, well, a technology is something that helps people accomplish some goal. It's some kind of, often they'll say it's something, that helps them achieve a goal. And I think that's a pretty good definition, and Brian Arthur would agree. So we can think of examples of these, some of them aren't really that high tech. I mean, a chair makes a great technology, right? We've had that for eons, and it's still a great technology. We can also think of a computer as a technology, right? So at the other end of the spectrum, an extremely complex system, that has software, hardware, all these different component parts working together. But we think of it as one kind of technology that's, composed of other parts. We could also think about technology in the plural, and often we talk about like fields of technology. So information technology is a good example, right? It's a collection of technologies that have to do with information. We could also, talk about woodworking technologies like you see here. And so there's different fields of, technology. Bioinformatics might be another example, right? And then finally, we might think about technology in a general sense, like, people in the United States have a higher level of technology or, capabilities or something than people in sub-Saharan Africa. So we can talk about, there was the Bronze Age, and then there was, the Information Age, recently that we're kind of in the midst of. So all of these are different ways of talking about technology. One important concept that I want you guys to take to heart is that technology isn't only physical things. So you can, look at these two images. On the left side, we see a car, and a car is like, a technology that I don't think anyone would argue about that. On the right side, maybe some of you have figured out what is in that picture. It's a bunch of people lined up making parts, right? So this was Henry Ford's perhaps greatest technological innovation, and that's the assembly line. And really, it's more of a process than a physical thing, although both of these have a component of, kind of hardware and a component of software, if you want to think of it that way. So Brian Arthur in his book talks about how, every technology is made up a bit of hardware and a bit of software, where he's using those terms loosely, not literally computer programming software, but he means a sequence of operation, some kind of process or method. So we can take the car and say, well, mostly it's a physical object. It's made up of like different things you can touch and feel. But there's also some sort of software within the car, if you want to think of it that way, even in old cars before computers, where we have, the way that things, connect, and the kind of design principles that are embedded in the car. And then we could think of the assembly line as being, mostly a process or a method for creating something. You line up people in a row, they each do a single task and then pass it on to the next person. But it has to be physically represented in some way. Like, we see a picture of people in it. So in any event, some of you may know that you can actually patent methods and processes. So even today, we think of technologies as not just physical objects. So this is a great quote by William Ogburn. The more there is to invent with, the greater will be the number of inventions. Maybe that seems obvious, but in the book, The Nature of Technology, Brian Arthur kind of unpacks this. He calls it combinatorial evolution. So, he contrasts in the book quite a bit between biological evolution and technological, or in this case, combinatorial evolution. He says, unfortunately, people have taken analogies of biological evolution, survival of the fittest, and tried to adopt those into how technology advances. But in reality, that's not a very good analogy. It breaks down quite a bit. So there might be some kind of analogy that sort of works, where you've got companies competing and only one of them might win out. That can certainly be the case where there's natural monopolies. But, like social networks, for example, there's some degree of that. But he argues that combinatorial evolution is quite different, because you can take component parts from all different kinds of technologies and mash them up way easier than we can with, through process of natural selection, where you don't really have that level of crossbreeding, if you will. So I think about this a lot in terms of Legos. So if I had, one Lego kit, then I could only make so many different things, right? Um, you give me another Lego kit, I can make not just the two things they come with, but I can now like combine them in interesting ways and make all sorts of, more combinations, right? It's combinatorial mathematics is like faster than exponential growth, right? It's super powerful. And let alone nowadays, it would be like, we have thousands of Lego kits all mashed together. I mean, the number of technologies that we have today that can be combined and integrated and woven together in interesting ways is just countless. It's a very exciting time to be around. And I remember, when I was younger thinking, well, have people always just felt like technology is changing rapidly and it's just my perception? Or is it really changing more rapidly? And I can tell you now, after living 45 years, like because of this principle, technology really is changing faster every year. In other words, we get more innovation per year now than we used to in the past, just purely because we have more Legos. We have, amazing things we can build with. Um, an important principle here that's related is this idea of modularity. So, not people have figured this out early, that um, if you divide different problems into um, distinct pieces, and then agree on how those interact with each other, you can have whole industries competing to develop this thing and develop that thing, and they can work together. So if you take like a standard PC computer, you've got industries competing on making a processor, right? And then they've got standards that say, okay, a processor can connect to a motherboard in this kind of way. And so if those are standard, then you can have really strong competition in the motherboard space, in the processor space, in the GPU space, in the um, hard disk drive or keyboards or mice, all these things. Once you agree on the protocols that let them share information or with each other and be interoperable, then you can get amazing innovation and competition. And so anyway, that's an important principle that helps combinatorial evolution happen. And we see it in software too. So for example, you've probably heard the term API, application programming interface. And what's cool is, like, if let's say I want to make a new what we call a mashup, where maybe I show, let's say, rest homes. I want to help my grandparents search for a rest home in a certain area, and I have a bunch of great data on rest homes, but I want to put it on a map, and I don't really want to build a map. Like, how would I go about doing that, and how would I get all the data for it? It's just not really feasible for someone doing a small project. But Google's already done that, and they've created an API that lets me use their mapping software by just like calling it in my code. And so, I mean, this happens all the time, right? So we leverage technologies that or software that other people have built to build other kinds of software. And so again, combinatorial evolution, right? We have all of these building blocks. I can take a facial recognition algorithm from AWS, and I can mash it up with some kind of webcam that I get from somewhere, and I can pull in a machine learning algorithm from Azure or whatever it is. You get the point. You can combine all sorts of things in interesting ways. And one thing that I think is fascinating about both the fields of IT and cybersecurity is that they're constantly dealing with complex systems, meaning that they're highly connected systems where things have unexpected implications because everything is so connected. And in IT, it's kind of fun because you can build new things by integrating parts, or maintaining. There's lots of different roles that people play, but um, part of this combination of different technologies is what makes it so fascinating and interesting. And in cybersecurity, there's just so many, because of the complexity of computing systems today, there's just all sorts of ways of getting things to do what people didn't expect them to do, and using that to your advantage or other people's disadvantage, right? And so, protecting systems and whatnot becomes a challenge. So here's just a visual representation of combinatorial evolution. And here we have the number of patents, and you see them growing, just dramatically over time, right? This just goes to 2010, but the same pattern continues. And so we see at least exponential, maybe more, in recent years of the number of patents filed. Here's another picture. So this one is from a web technologies kind of diagram. I use this sometimes in 210, our web technologies class. And you can see, back here in the early 90s, Tim Berners-Lee invented HTTP and HTML, and the first browser emerged. And then we have, Netscape, which was the first popular browser in kind of the mid 1990s. And then we have some new technologies that kind of build on top of those. So once you have those existing, we can then add on things like CSS or Ajax or Canvas, or, and so on and so forth. Well, eventually this visualization just doesn't really work. And this stops in like 2012. I don't think anyone's updated it, probably because it didn't work. There's just too much going on, right? Like people, they have so many Legos to play with. They just keep building and building and building and building. But one thing that's super important about our field is that if you don't understand the basics, the underlying technologies really haven't changed that much. We still have IP addresses that make the internet protocols work. We still use HTTP, the protocol of the web that Tim Berners-Lee created. Of course, we've added lots of things. We added on a security layer, right? HTTPS, where things can get encrypted. And we've added on now like front-end frameworks. So maybe you've heard of React or Vue or Angular. They're kind of technologies that build on top of CSS and JavaScript, which build on top of the capabilities of the browsers that have been built in. And all of that works on top of the internet, which has been around for a long time. And even though things like IP addresses, sometimes we have like new versions of them come out, like IP version 6, a lot of it still runs on IP version 4, the majority now. That'll probably change soon, but it's taken a while. But it's still the same concepts. So in any event, that's, technology unfolds at a pretty rapid pace, which is exciting. I mentioned before, you can see my backdrop here in the Computer History Museum. They have a really cool exhibit called the Revolutions exhibit that takes you through the first 2,000 years of computing up till the year 2000. And I was going to show you just briefly some of the technologies that they spotlight. And I'm not going to go through all these, but this is a super fun website to kind of explore. So they start off with talking about calculators, things like the abacus. I remember on my mission where people would use an abacus. If you think about it, what is an abacus? It's basically external memory, right? I don't have to keep all those numbers in my head. I can just use something easily to help me add, and subtract. We can also look at, so these were like early, calculators. We moved later to things like punched cards. The Jacquard loom was one of the early predecessors. It was like, it would weave cool patterns based off punch cards. And then some people said, you know what, we could use punched cards for like tabulating data, like in the census records. And so in the early 1900s, they did that. They'd punch these cards and then they'd put them in these machines. and then the machines would run through all the cards and have these dials that would just crank up and count how many people there were in different areas, right? So kind of fun. And then eventually we move up to analog computers, which were based off of, not discrete math, but continuous math. And then digital computers, which we ended up, kind of pursuing more than analog computers. And then, we talk about in World War II, a lot of the computing, the need to calculate things like missile trajectories or to work on encryption and decryption became more important. I had the chance to go to Bletchley Park in England and see where Alan Turing lived and worked on his the computers that helped decrypt um, the German tools that were, they were using to encrypt messages. So anyway, the exhibit's really fun. There's parts of it where you can go through and find, like early computers, and they talk about mainframes. This was the era where, before people had computers at their homes, you would have like a big building where a computer would reside, and they'd use vacuum tubes instead of transistors, and they were like huge. In fact, when I was at Michigan, the building that the School of Information was in, where all the faculty and grad students had our offices, it was where the old mainframe computer used to be. Didn't have too many windows. That was the one downside. Now they have a nice new building. But anyway, yeah, just lots of other, cool things that have come about. Of course, programming and programming languages became an important thing. There were just, fascinating stories. I don't know if you guys have seen, oh shoot, now I'm blanking on the name of the movie that spotlights some of the early computers. Computer was a term for people that did computations, right? And so that we ended up using it for, devices that could do computation, but originally it was people that did those computations. So anyway, eventually we got mini computers and we started to have those at our homes, and then we, have worked on all sorts of other, things, computer games, personal computers, mobile computing, networking, and the internet, all of that. So anyway, if you want to play around, this is a great site to kind of explore. Let me jump back here and just share one of my favorite quotes. This is from Howard W. Hunter, 1995. So I was on my mission in Russia at this time. I had no idea what the internet was. He's talking, I think, about, in this case, he was talking about family history technologies, but I think also just more generally, the role of technology in furthering the work of the Church of Jesus Christ of Latter-day Saints. And I love this, phrase that like, this work has been accelerated by the Lord himself, who has had a guiding hand in its development and will continue to do so. We stand only on the threshold of what we can do with these tools. I feel that our most enthusiastic projections can capture only a tiny glimpse of how these tools can help us and of the eternal consequences of these efforts. I mean, I think even having said that, President Hunter would be thrilled and awed by the ways that we're using technology right now to further the work of the church, especially things like family history. I mean, I think it's so great. We can like pull out our phone, record audio of, when our grandparents talking, upload it to the cloud, snap a picture of them, upload it, and anyone in the world can view that story, listen to it. That those concepts just we're so far in the future at this time. The idea that we have this kind of massive family tree that we're creating, and now the role of things like genetics and genealogy. It's just amazing. So we live in a wonderful time. What a great field to go into, where we can, influence the world for good in the ways that we either create or work with, or empower people with technology, as well as protect people from those who want to use it for nefarious purposes. So I think I'll stop there. It's been, a pleasure to spend a few minutes with you. And let's see if I can stop sharing here. All right. So I hope to meet you in person. If you ever want to reach out, feel free to send me an email or find me in my office someday. Maybe not this COVID-19 semester, but if we use this video in the future, hopefully I'll be a little more accessible in person. I look forward to having you guys and seeing you in future classes. I often teach IT&C 210, our web technologies class, 350 databases, 231 ethics, legal, and globalization issues. And then I help with lots of other stuff, seminar and capstone. And I also have taught HCI and yeah. So anyway, we'll talk to you later and have a great day.